Hello, everyone. Those who are still struggling with financial maths, especially grade 12 annuities, please watch this video. I hope it will help you a lot. Do not forget to like, share, and subscribe. Annuities. Let's look at some of the things that you need to remember as you are preparing for your exam or for your test. So now, what is annuity? An annuity is a series of equal payments or a number of equal payments. And not only payments, it can be withdrawals, it can be deposits. So these withdrawals or payments or deposits must happen in a regular time interval. For example, you are paying every month, you are paying every 3 months, you are paying semi-annually, you are paying every year. So that is a regular time interval and subject to an interest rate. Now, we have two different types of annuities in grade 12. There is a future annuity where you are saving for the future. There is also a present annuity. So in present value, so I will start with present value. So present value is the money that you can use now. For example, if you go to the bank and take out the loan, you are taking out the loan because you want to use that money now. There is no way that you will take a loan and say, okay, I'm taking a loan today, but I want to use that money in 3 years' time. So now, let's look at present value formula. So the present value formula is given by P is equal to X into 1 minus into 1 plus I to the exponent negative n, all divided by I. So now, in this formula, P represents your loan amount. That is your present value, the money that you can use now. Or if you have inherited some of your parents' investments, so your P can also represent the inherited amount. And then X represent equal payments or equal withdrawals. So now the minute you see the word withdrawal, so this tells you that we are dealing with the present value. The minute you see word withdrawal, the minute you see word loan, you must know that we are dealing with present value. And then N, our N here represent the number of payments or the number of withdrawals. So how many payments are you going to make? How many withdrawals are you going to make? That is your N, the number of payments or the number of withdrawals. And then we have I. So I represent your interest rate. So if you are given 21%, remember, you need to take 21 and divide it by 100. So we are going to write our I as decimal. Now, in this formula, you must be able to calculate the value of P. You must be able to calculate the value of X. You must be able to calculate the value of N. You must be able to calculate P. You must be able to calculate X. You must be able to calculate N. Okay. Now, we also have outstanding balance. After you have made a certain number of payments, you need to know how much are you still owing. You go to the bank and ask them the outstanding balance. How much is outstanding? Now, to calculate the outstanding balance, we use this formula here. There are two methods, in fact, but I will stick to this one. So the outstanding balance is given by OB is equal to, now if you look at these formulas, they are exactly the same. So however, if you are calculating an outstanding balance, instead of n, you put the number of remaining payments. So for example, if you were supposed to make 10 payments and you have made 2, so that means your n will be 8. So you put the number of payments that are remaining. How many payments are remaining? So that is your n when you calculate an outstanding balance. After outstanding balance, you must be able also to calculate interest paid. So interest paid in 1 year, 2 years, 3 years, and so on and so on. So now to calculate the interest paid, we use the formula X. Remember we said X represent the equal payments, multiplied by, this is a multiplication here, it is X multiplied by the number of payments made. So how many payments have you made? So for example, if you are paying every month and you have paid for 1 year, so that means you have made 12 payments. And then minus into your loan amount, this is your loan amount, and then the outstanding balance after you have made those payments. So it is X multiplied by the number of payments that you have made, minus your loan amount, minus your outstanding balance after you have made those payments. Okay, that is your interest. And then you also need to remember how to calculate the final payment. So we also have final payment that we need to remember. So now to calculate the final payment, you need to first find the outstanding balance immediately after the last full payment. You need to find the outstanding balance immediately after the last full payment. And that outstanding balance after the last full payment, you just multiply it by interest for 1 period. This is interest for only one period. Let's go straight to application, or let's go straight to examples. Now here is example number 1. Let me just zoom a little bit. All right. Here is example number 1. A loan of 50,000. So we can see already here, this is a loan. So this is your what? This is your P. So P is 50,000. It's to be paid off by monthly payments over a period of 4 years. Now, monthly payment, that is a keyword. The loan is being paid every month. That is a regular time interval from our definition. Okay, over a period of 4 years. So if you are paying every month for a period of 4 years, so that means that the number of payments that you are going to make, you are making 12 payments each year. So it will be 12 multiplied by 4 years. So it will be what? It will be 48. So here, your N will be 48. If the interest is 12% per annum compounded monthly. So if the interest is compounded monthly, now that means your I here will be 0.12. I have already divided by 100 over what? Remember, 12% is the same as 12 over 100. Because it is compounded monthly, it must be over 12. And then the first question here, we are required to calculate the monthly repayments. So every month, how much is this person going to pay? So we are looking for that value of X. But before we even start with the value of X, we need to write our formula first. So that means A here, we are going to have P is equal to X into 1 minus 1 plus I to the exponent negative N all divided by what? All divided by I. And then from here, we do have our loan amount. Our loan amount is 50,000. So we just put 50,000 here. We have 50, 1, 2, 3 is equal to, we are looking for X, monthly repayments. So into 1 minus, so 1 plus our interest is 0.12 over 12. And then to the exponent, negative 48. Close the bracket, all divided by 0.112 over what? Over 12. And then from here, we are looking for X. So we can cross multiply first. So if I cross multiply here, and then we can cross multiply and divide by a bigger bracket. So our X is going to be X is equal to, and then 50,000, 1, 2, 3, cross multiply by this denominator. So it is multiplied by 0.12 over 12, and then divided by the bigger bracket. So we want to solve for X, so we must divide with everything a number no X. So divided by 1 minus 0, this is 1 minus 1 plus 0.12 over 12 to the exponent negative 48. Then close the bracket. So here X is equal to, and then now calculator will give us 1,316.69. So every month this person will pay 1,316.69 for a period of 4 years. That is number one. And then number two, calculate the outstanding balance immediately after 12 payments. So after this person has made 12 payments, how much is this person owing? So the formula for outstanding balance, this is our B. So it is OB is equal to X into 1 minus 1 plus I to the exponent negative n, all divided by I. Remember we said where there is n, we just put the number of remaining payments. Remember, this person in total was supposed to make 48 payments. So 48 payments, and then 12 payments have been made. So that means the remaining payments will be 48 minus 12, it will be 36. So where there is n, we are going to put 36. Now, okay. So we are going to have, this is equal to, and then now our X, we calculated our X as 1,316.69 into 1 minus 1 plus 0.12 over 12 to the exponent. The remaining payments, after 12 payments have been made, so it will be 36. And then you close the bracket, all divided by 0.112 over 12. And then this is equal to, so calculator will give us, so we are getting 39,642.30. So you will also verify. So this is my outstanding balance. So after 1 year, this person is still owing 39,642, comma 30. This is the amount outstanding after 12 payments have been made. Number C. Let's check question number C. Calculate the interest paid after 1 year or in 1 year. Calculate the interest paid after 1 year. So to calculate the interest is equal to X times number of payments that have been made minus our loan amount minus outstanding balance after 1 year. Now, so we calculated our X as 1,316.69 times after 1 year. How many payments have been made? It is only 12 payments that have been made. And then minus, what is the loan amount? The loan amount is 50,000. And then minus, what is outstanding balance after 1 year? We calculated our outstanding balance as 39,642.30. And then this will give us, it will give us 5,442.58. So this is the interest paid in 1 year. So in 1 year, the interest that have been paid is 5,442.58. And then we are done with example 1. Let's go straight to example number 2. Example number 2. Okay. Here, let's see. Tando borrows 5,000 from the bank. So this is a loan again. You can see we have a loan at an interest of 21% compounded monthly. She repays the loan by means of equal monthly payments. That is a keyword again. The loan is being paid by equal monthly payments of 800. So every month, that is a regular time interval, monthly. So every month, this person is paying 800. And the final payment of less than 800. Now, we can see that here. What is it that we have? We have our P, the loan amount. We have our X, equal payments. We also have our I, the interest. So which is what? 0.21 if I divide this by 100. And then because it is compounded monthly, so it will be over 12. And then now, from here, we are required to find the number of payments. How many payments? That is N. We are looking for N. Okay, now we write our formula. So which is P is equal to X into 1 minus 1 plus I to the exponent negative N, all all divided by I. And then from here, it will be substitution. So if I substitute, I'm going to have our P is 5,000. Not 5, yeah, it is 5,000 is equal to our X, it is 800 into 1 minus 1 plus 0.21 over 12. We are looking for N. All divided by 0.21 over 12. Now from here, I am going to cross multiply, so I will multiply everything by 0.21 over 12. Then I will divide by this 800 on both sides. Now, I'm going to have 5,123 times 0.21 over 12. And then on both sides, we divide by 800. So this will be over 800 is equal to, now, 1 minus 1 plus 0.21 over 12 to the exponent negative n. Now I am going to transpose this one. If I transpose 1, I am going to have 5,000 times 0.21 over 12 divided by 800 and then minus 1. This is equal to negative 1 plus 0.21 over 12 to the exponent negative n. Now this will give me, it gives me minus 57 over 64 is equal to negative 1 plus 0.21 over 12 to the exponent negative n. And then I can see that on both sides I have negative, even here I have negative. I can just divide by -1 throughout. So if I divide by -1 throughout, I will remain with 57 over 64 is equal to now positive 1 plus 0.21 over 12 to the exponent negative n. Now n that I am looking for is an exponent. So I need to introduce logs here. So I will have negative n is equal to log. This is my base. My base is 1 plus 0.21 over 12 of a number. The number is 57 over 64. Okay, and then this will give me negative n is equal to, now, negative 6,677,09,335. So therefore, my n is equal to 6,677,09,335. So now you need to understand. So this person will make this number, this whole number here, represent the full payments. So this person will make 6 full payments. So here, there are 6 full payments. And plus final payment, which is smaller than the monthly payments. So now, in total, this person will make 7 payments. Here, I am not rounding off. So these 6 represent full payment. And then the decimals here, they represent the payment that is smaller than the payment that is being made every month. So 6 full payment and 1 payment that is not full. So in total, there are 7 payments. But the payments that are full, they are only 6. So the question, let me check. The question was, calculate the number of payments at 800. They are specific. They are looking for full payments. How many full payments? Therefore, the answer here will be, payments of 800 will be 6. So payments at 800 they are 6. So payments at 800, they are 6. Okay, let's check the last question here. Now, we have calculated N. Now, we are required to calculate the outstanding balance immediately after the last full payment. The last full payment is the 6th payment. So we are calculating the outstanding balance after 6 payments have been made. All right. So let me erase here so that, okay, or maybe I can write this side. Okay. So now, so to calculate the outstanding balance, we use OB is equal to X into 1 minus 1 plus I to the exponent negative N, all divided by what? All divided by I. So this is equal to X is 800, okay, into 1 minus 1 plus 0.21 over 12. And then now, your N is the number of remaining payments. So you just take the number of payments and subtract the payments that have been made. So from this number that we got here, we are going to subtract 6 because we are calculating the outstanding balance after the last full payment. And the last full payment is the 6th payment. So 6 payments have been made. So we are going to remove 6 from this. Now, if we remove 6 from that N, we will remain with negative 0.6767093335. So you must write the entire number. Then close the bracket, all divided by, do not round it off, all divided by 0.21 over 12. So our outstanding balance immediately after the last full payment, OB, is equal to 533.54. So this is our outstanding balance after the last full payment. Okay, let's check the last question. Determine the value of the final payment. Remember to calculate the final payment. So final payment is given by OB after full payment into 1 plus I. So we multiply it by the interest of 1 period. So here, to get our final payment, this is C. So we will take this outstanding balance after the last full payment, which is 533.54 into 1 plus 0.21 over 12 for 1 period to the exponent 1. So our final payment will be 542,88. So this is our final payment. Delayed and missed payments. So let me start with delayed payments. Now, if you are taking out a loan, so if you are making, or if the agreement is to make monthly payments, so every month you must make a payment. So if you are taking a loan here at T0, so here at T0, the loan is taken out. So it is normal to make the first payment in 1 month's time. So if you are paying every month. So at the end of the month, you must make your first payment. And then you continue to do so until you finish your loan. So here, you pay every month. So T1, you make a payment. T2, every month you must make a payment. So from T1 until you finish your loan. So this gap is always allowed. So this gap is always allowed. You cannot take a loan at T0 and start paying at T0. So you take a loan today, in 1 month's time, if you are paying every month and your interest is compounded monthly, you must make a payment. But now, if you take a loan at T0 and then at T1, you do not make a payment. Remember, here you must make a payment, but at T1, you do not, no payment. You do not make a payment. At T2 again, this is in 1 month's time, no payment. 2 months later, no payment. 3 months later, no payment. And then maybe you start paying in 4 months' time. So here you pay your X amount. So now that means during this period where you are not making payments, so for these 3 months where you did not make a payment, so remember, if you start paying in 4 months, so whatever amount that you took from the bank will grow in a compound interest. So these delays will affect your P. Now, the P that you are going to substitute in present value formula, you are going to multiply that P by 1 plus I if you start paying in 4 months. So it must gain interest for that 3 months period. That means if you take a loan and start paying in 1 month, you will not do anything. You will substitute your P as it is. But if you start paying in 2 months, your P must gain interest for that 1 month because 1 month gap is allowed, or 1 month period is allowed. And then if you start paying in 3 months, your P will gain interest for 2 months. If you start paying in 4 months, your P will gain interest for 3 months. If you start paying in 10 months, your P will gain interest for 9 months. I will take you through examples after this explanation. Now, let's look at this one. If the interest is compounded quarterly, so that means every 3 months you are making payments. So remember, the quarter is divided in 3 months. So that means it is normal to start paying in 3 months. So month 1, month 2, and month 3. And then here you must make a payment. So, and then another payment will happen in 6 months. So if you are paying quarterly, the first payment must happen in 3 months. So one gap is 3 months. Now, but if you take a loan here, after 3 months, you are not making any payment, no payment. In 3 months, no payment, and the interest is compounded quarterly. In 6 months, maybe you make your first payment. In 6 months, you make your first payment. So that means, remember, 3 months gap, if the interest is compounded quarterly and payments are being made quarterly. So 3 months gap is allowed. It is normal. You take a loan, you pay in 3 months. But the minute you start paying in 6 months and the interest is compounded quarterly, so that means there is one gap that you missed. So your P will be affected again. So you are going to have P into 1 plus I, and then 1 period that you missed to the exponent 1. Because here you only missed 1 period because you started paying in 6 months instead of 3 months, because your interest or your payments are being made after 3 months, which is quarterly. Now let's look at the missed payments. So the missed payments, let's say your loan, for argument's sake, is paid every month for a period of 1 year. So if you take a loan at T0, so the loan amount is taken out here. And then the first payment must be made at T1. You make a payment at T1, no problem. You make a payment at T2, no problem. You make a payment at T3, no problem. And then again, you make a payment at T4, no problem. And then after you have made your fourth payment, your fourth payment, you now experience financial difficulties. And you are now unable to make your fifth payment, your sixth payment, and your seventh payment. So after missing these 3 payments, you have now missed 3 payments. After missing these 3 payments, again, you are able now, again, maybe you get a job. If you've lost your job, you get a job again, and you start, or you continue with, or you want to continue with your payments. So, which will start at T8, T9. And then you still want to finish your loan here at T12. Remember, there are months that you have missed already. So what will happen here? Now, for you to finish this loan, that means whatever that you are paying here must be increased. The X that you are paying there must be increased so that you are able to finish your loan at T12. So with missed payment, they will ask you to calculate the increased monthly payments or the increased equally payments. Now, how do you calculate that? So I will take you through example, but now what is it that you need to note here? So here everything is well. So now for you to find these increased payments, you must first know what was your outstanding balance before you missed all these payments. How much were you owing? So we need to calculate outstanding balance after the fourth payment. This outstanding balance will now grow. Remember, during this period, there is no annuity because there are no payments that are being made in a regular time interval. So whatever amount that you are owing here will grow in a compound interest for the months missed. So it will be outstanding balance. You must find it first. Into 1 plus I to the exponent. How many months have you missed? 1, 2, 3. So to the exponent 3. And then you will get your new present value here. So that present value, you are going to continue with it for the remaining period. For 1, 2, 3, 4, 5. So now you will calculate X using that new present value that you are going to get here. And then you calculate X using the same interest. And then you'll have your, and then, yeah, you will be able to find the new value of X. But you will see as we do our example. Now let's look at this example here. A loan, this is a keyword again, a loan of 42,000 is repaid by equal monthly installment of 3,300. Again, by equal monthly installments. That is another keyword. So we already know that we are dealing with annuity here. And the final payment, F, of less than 3,300. Payments begin or begins 6 months after the granting of the loan, the payments are being delayed. So now we can see that our interest here is compounded monthly and payments are being made every month. Now here is the story. So now this person at T0 takes out the loan of 42,000. So now if you are paying every month, the first payment must happen here at T1. There is no payment. There must be payment at T2, no payment. T3, T4, T5, and then T6. And then after 6 months, the first payment is being made. So now that means this person did not make 1, 2, 3, 4, 5 payments. So now during this period where there are no payments, this loan amount that is in the bank will be growing in a compound interest. There are no payments that are being made, so that is not an annuity at the beginning, because for annuity there must be equal payments that happen in a regular time interval. If there are no payments, so the amount that is in the bank will be growing in a compound interest for 5 months, because at T6 the payment is being made. Now the interest is calculated. Okay, I did read that one. Determine the number of payment at 3,300. Okay, step number 1 here. This delay will affect our P. So now let's calculate the amount payable at T5. So amount payable at T5 so is equal to, and then we take this 42,000, 1, 2, 3 into 1 plus our interest here is 0,215 over 12. How many months were missed or delayed? It is 5 months. This is equal to, then now we will get 45,899,76021. Now this is our P for present value formula. So our P is affected because there are payments that were not made. So during that period, your loan amount will grow in a compound interest. So this is our P. Now to calculate the number of payments, so we are going to write our formula. So P is equal to X into 1 minus 1 plus I to the exponent negative n, all divided by what? All divided by I. Now, so P is no longer 42,000, but it is 45,899, 76. This is equal to our X is 3,300 into 1 minus 1 plus 0,215 over 12. We are looking for n to the exponent n, and then all divided by 0,215 over 12. And then from here, we are going to solve for n. So we will cross multiply, then divide by 3,300 on both sides. So I'm going to have 4,5,899,76 times 0,215 over 12. And then on both sides, I'm going to divide by 3,300. So divided by 3,300. This is equal to 1 minus 1 plus 0,215 over 12 to the exponent negative n. And then this one will give me this is 0,24920 324 36 is equal to 1 minus 1 plus 0,215 over 12 to the exponent negative n, and then transpose 1. So if I transpose 1 here, I am going to have negative 0,75 079 96 75 64 is equal to negative 1 plus 0,215 over 12 to the exponent negative n. Now I can see that I have negative on both sides. I can just divide by negative 1. So now if I divide by negative 1, negatives will go away. And then to find n, I will say negative n is equal to log base 1 plus 0,215 over 12. And then of a number which is 0,75 07 96 75 and then 64. So my n here will be, I'll get negative on both sides, so I will again divide by negative. So my n is 16,140,297,84. So now that is your value of n. Now remember, the question was very specific. We are looking for number of payments at 3,300. So we are looking for full payments. So remember earlier on we said this 16 here represent full payments, and then the decimals here, they represent the payment that is not full, so which is the final payment. So here in total there are 17 payments, but the answer here you'll say 16 payments at 3,300. So the payments at 3,300, they are only 16. There is another payment, but that payment will be smaller than 3,300. That is question number 1. So the answer is 16 payments. Let's check question number 2. Calculate the value of the final payment. So final payment is given by OB after the last full payment. Into 1 plus I to the exponent and then just 1 period. Now, the outstanding balance after the last full payment here, the number of full payments, they are 16 in total. So we need to calculate the outstanding balance after 16 payments. So it will be OB is equal to X into 1 minus 1 plus I to the exponent negative n, all divided by I. So our X is 3,300 into 1 minus 1 plus 0,215 over what? Over 12. Now, how many payments are remaining? So you just take your number of payments and subtract 16. So you will get 0,14029784, and then all over 0,215 over what? Over 12. And then from here, this is equal to our outstanding balance immediately after the last full payment is 458,31. Now, this is not our final payment. So therefore, our final payment is 458,31 into 1 plus 0,215 over 12. To the exponent, you just give it interest for one period. So our final payment will be 466,52. This is our final payment. And then let's check. I think there is another question here. The last question here, we are required to calculate the outstanding balance after the 9th payment. So, outstanding balance after payment number 9, okay? After the 9th payment, you just say OB is equal to X into 1 minus 1 plus I to the exponent negative n divided by I. So this is equal to our X is 3,300 into 1 minus 1 plus 0,215 over 12 to the exponent negative. Now, from our n that we got, if we remove 9, we will remain with 7,14029784. That is the number of remaining payment. So all divided by 0,215 over 12. And then our outstanding balance after the 9th payment is 21,934,39. So, and then we are done with that question. So that is how you accommodate delayed payments. So the only thing that is affected by delayed payment, yes, it will be your N as well as what? As well as your P. Because now you can see that our P, we did not use 4,200, but we had to find the amount payable first. So this person started paying after 6 months. So that means month number 1, month number 2, month number 3, month number 4, and month number 5, the person delayed. So that is why the loan gained interest for those 5 months. And then you take this accumulated or this amount payable, and then you put it where there is P, and then you can start with your calculations. And then last example. So in the last example, we are dealing with missed payments. So let's see how to accommodate missed payments. Now, here is the last example. So David purchased an internet cafe for 1.8 million. He paid a deposit of 60% and financed the balance through the banking institution. So now, with this one, so this person did not take 1.8 million from the bank because 60% is paid as a deposit. So if 60% is paid as a deposit, that means it is only 40% that will be a loan. So the loan amount here will be, if we want to calculate a loan amount, so loan, it is only 40% because 60% is a deposit. So we'll just say 1.8 million multiplied by 0.4, so which is the same as 40%. So it will give us our loan amount as 720,000. So this is our loan amount. This is our P. Now, the bank offered him a loan which had to be repaid at the end of each month at the interest of 8% per annum compounded monthly. The first payment is 1 month. So 1 month is normal. So if you take a loan today, the first payment must be made in 1 month's time. Now, the first question is, show that the monthly installments in the nearest rent is, so we need to prove this. Okay, the period is 10 years. Now, we write our formula first. So P is equal to X into 1 minus 1 plus I to the exponent negative N, all divided by what? All divided by I. Okay. Now, what is our loan amount? The loan is 720,000, not 1.8 million, because 60% is paid in cash. This is equal to X that we are looking for. 1 minus 1 plus 0, the interest is 8%, so it's 0.08 compounded monthly over 12 to the exponent negative. It is 10 years, so it will be 120, because in 1 year or each year 12 payments are being made. So for 10 years it will be 120. So all divided by 0.08 over 12. And then here we are going to cross multiply and divide by a bigger bracket. So if we do that, we are going to get our X is equal to 720,000, 1, 2, 3, multiplied by 0.08 over 12, and then we divide with a bigger bracket, which is 1 minus 1 plus 0.08 over 12 to the exponent negative 120. And then our X here will be, okay, let's see, we are going to get 8735,586. Now to the nearest rent, so this number is bigger than 4, so this number will change. So it will be 8736. So that is your X. We are done with the first question. Let's check question number 2. Now, based on the monthly installments of 8,736, calculate the outstanding balance of the loan after 3 years. So after 3 years, that means 36 payments have been made. So this is after 36 payments. So the remaining payments from 120 will be 84. So 84 payments are still remaining. Now, the formula for outstanding balance, OB, is equal to, and then let me just substitute straight. So we do have our X as 8,736. 8,736 into 1 minus 1 plus 0.08 over 12. So now, how many payments are remaining? It is 84, all divided by 0.08 over 12. And then from here, our calculator will give us our outstanding balance as, okay, let me see. So we are getting our outstanding balance as 560,000. 495.31. So this is outstanding balance after 3 years. After 36 payments have been made, so the number of payments that are remaining, it is only 84. So this is our outstanding balance. And then the last question here now, due to financial difficulty, David misses the 37th, 38th, and 39th payment. Calculate his increased monthly payment, which comes into effect from the 40th payments onwards. Now, here's the story. So this person, took out a loan here at T0. T1, the person made a payment. T2, the person made a payment. This person made payments until T36. Now, the last payment that was made was at T36. Okay, this is not T3, but this is T36. Now, at T36, after making this payment, and then T37, no payment. T38, no payment. T39, no payment. And then T40, he wants to start with increased payments. All right, now, what is it that you need to note here? So after this person made the 36th payment, the amount the person is owing is 560,000. This is the outstanding balance after the 36th payment. Is 560,495.31. Now, this amount this person is owing at T36 for 3 months, because here there are no payments that are being made. For 3 months, it will grow in a compound interest until T39. So let's get our new loan amount at T39. So we are going to grow this amount by 3 months. So where there are no payments that are being made. So we are going to say 560,495.31 1 plus 0.08 over 12 to the exponent. For how many months? It is for 3 months. Now, we are going to get the loan amount at T39 now. So at T39, this person is now owing, after the outstanding balance has grown by 3 months interest. This person is now owing 5,7,1,780, 11. Okay, now this is our new loan amount. This is our new P. So going forward from T39 to T120, from T39 until T120, we are going to use this P to calculate the new value of X, or increased value of X. Now, we are going to write our formula again. P is equal to X into 1 minus 1 plus I to the exponent negative n, all divided by I. Okay, so our new present value is 571,780,11. This is equal to x that we are looking for, the new x increased one, minus 1 plus 0,08 over 12. And then now from T40 to T120, so, or from T39 to T120, now our n will be 84, because from T36 we said 84 payments were remaining, and then minus 3, minus this 3 here, and then we have not 84 but we have 81. Not 84. This one will be 81, and then all divided by 0,08 over 12. And then now solve for x here. This will give us x is equal to 9158,60, and then we are done with present value. So in the next video I'm going to deal with future value.